Hi everyone, we're going to solve each log equation, and there's two things you need to know. The common log is basically log base 10 of x, and if you ever see log of x, that means it's base 10. So most books don't put base 10, they just leave it like that. Natural log can be written as log base e of x equals ln of x. And this set I'm doing is from a worksheet a student that I tutor gave me. And there's a problem on this that we have to know that ln, which is the natural log, of e equals 1. So what we're going to do to solve these is rewrite these in exponential form, because that is something we're used to. If you do these a lot, you could probably solve these without rewriting it. But the first thing we're going to do is rewrite it and then solve, because that's what you're used to. So my base here is 2, and my power is always on this side. So 2 to the 5th equals x, and you merely simplify this 2 times 2 times 2 times 2 5 times would be 32. So 32 equals x. Alright, and then we have a bunch of problems here. So here we go. This one, this is the same one, so I'll just do it again. 2 to the 5th equals x. So that's x is 32. This one is 2 to the yth power equals 8. So in this case, you can either just do this in your head and realize that y equals 3, because 2 to the 3rd power is 8, or you can write this using the same base, but then you still have to know that 2 to the 3rd power is still 8. So we have that y right here, y equals 3. Okay, on this one I'm going to rewrite b to the 2nd power equals my value of 49. So if you square root both sides, most of you are going to say b is 7. However, when you square root both sides, you put the plus and minus, we know that b equals plus or minus 7. Okay. Next one, we're going to rewrite this. Now this one we can't do in our head very well, so I'm going to write 2 to the 5th power equals my value, which is x minus 1. So what we have is 32 equals x minus 1. If you add 1 to both sides, you get x equals 33. On this one seems to be out of place with this worksheet. So basically, you have ln of e squared. And there is a section I'm going to be doing later that talks about this. But basically, we're going to use our power property and move this 2 in front. So we get 2 times ln of e equals y. Well, ln of e equals 1. So basically, we get 2 times 1 equals y. Therefore, 2 equals y. Again, this one's a little out of place. Okay, the next one. This one doesn't have a base, so that means it's base 10. This is your common log. So let's rewrite it. 10 to the 0, this is your power, equals x plus 4. Any base to the 0 power equals 1. So we know this equals 1. So we have 1 equals x plus 4. Subtract 4 from both sides. So you get x equals negative 3. And on these, you always want to check to see if it satisfies the equation. So when you plug in negative 3 into there, this quantity here has to be positive. So A has to be positive, the quantity there. And it is, so this does work. Okay, this one, 7 to the white power equals 1. In that case, you have to know that y is 0, because anything to the 0 power equals 1. Or, you could think of it this way, I could write this 7 to the white power equals 7 to the 0th power, because 7 to the 0 is 1. And then you just see that y equals 0. Okay, this one we have 3 to the x power equals 9. So we know right away, just by looking, that x equals 2. Or again, you could write it as 3 to the x equals 3 squared. And then you see that the x equals 2. 5 to the x power equals 1/5. Now in this case, we should know that x equals -1, because anything, let's say a to the -1 equals 1 over a. Or you could write this as 5 to the x equals 5 to the -1, and there we have x equals -1. Okay. Next, this one is more of evaluation. So I'm going to go ahead and write that we're looking for our p, our power. So I go ahead and if I see something like that, I go ahead and put it equal to the power. So b to a certain power equals 1. And like I said before, that means that p equals 0. Because anything to the 0 power equals 1. Or you could write it like this, because you want to have the same basis. So p equals 0. In this case, we have b to a certain power equals b. In that case, b equals 1. You could even write the 1 right there. Okay, next one. It's the last one. I'm going to go ahead and set this to a power. So we have b to a certain power equals 1 over b, and this is very similar to the one we just did. We can write this as b to the power equals b to the -1. That means we have p equals -1. And that's all. Thank you. Have a nice day. Bye-bye.